Welcome back. So today we're gonna start a topic named IUPAC. IUPAC. Yeah, you can pronounce it whatever you want. But first of all, what is IUPAC? It's not a chapter. It's a union. It's a committee. It's a society which was set up in 1919. The full form is International Union of Pure and Applied Chemistry. You might wonder why. See, before 1919, I mean even after 1919, there were thousands of compound, and like different countries were progressing in their chemical fields, and naming shits differently. So what they came up with, they set up the committee or a union to name every compound theoretically. So I mean, like, they form some basis of, like, you can say, a language in which we can term these compound, and it came out International Union of Pure Chemistry and Applied Chemistry. What is the difference between pure chemistry and applied chemistry? That's a good question. Pure chemistry is something we do, on paper, like this shit type. It's always accurate. I mean, at least in notebooks. And what is applied chemistry? Applied chemistry is something like, see, in reality, the certainty of a solution is zero. I mean that if you mix shit and some, I mean, like, if you mix something and you wanted the result that something theoretically, then it's not 100% sure that it will come out that. Yeah, basically, you mixing something and you make a health potion out of it, but your partner makes the something and it blows up. So yeah, there's no surety of it, and it's called applied chemistry. Basically, it's the industry level of chemistry where, like, all the medicines and things are made up. And pure chemistry is academic, yeah, schools one. So let's start with basic. Wait a minute. First we should know the importance of IUPAC. People think IUPAC is a basic, like, it is basic of organic chemistry, but like it is so basics that they don't go through it. But they're actually wrong. Like, in NEET or JE Advanced, there are questions from IUPSC. Like, imagine one or two questions from IUPSC. That's the level of importance of this thing. Oh my god, my cold hasn't cured. Anyways, let's start. Ooh. So in this chapter, we're gonna learn naming of hydrocarbons. Wait a minute. Yeah, naming of hydrocarbons. Hydrocarbons. My shit handwriting. What are hydrocarbons? See, hydrocarbons are the carbons which make bonds with hydrogen atoms. You might ask how. See, carbon have 4 electrons in the outer shell, so it can either form 4 pairs or either donate these 4 electrons. Hydrogen have 1 electron, so what happens, that carbon pulls this hydrogen onto him, and, like, with H H H, it makes its second shell stable, so it comes out like CH4. As simple as that. Yes, this is nomenclature. I mean, you can say that this is all there is for naming of hydrocarbons. How you will represent these bonds? In chemistry, we represent the bonds by this, bondings by this, a line, CH H H. This is a bond, not the relationship one, but the chemistry one. This is a bond. Neither the James Bond, but it's the chemistry bond. Okay. So C, carbon atom is forming bonds with 4 hydrogen atoms, CH4. Easy, dude, easy, super easy. What are these bonds called? There are types of bonds too. Yep, there are two types of bonds: sigma bond and multiple bond, also known as pi bond. Majorly, you will call it pi bond. Now, sigma bond is only of one type, but multiple bond are of two type: single pi bond or double pi bond. So basically, this you can see one line is called sigma bond. For this sigma bond, that's it, sigma bond. But pi bond is something like, so wait, how you will count how many sigma bond is there? One bond, two bond, three bond, four bond, four sigma bond. And now coming over to multiple bond, of also known as pi bond, it is represented such as this, two lines. See what's happening here. Carbon is pairing up its two electrons with other carbon's two electrons, like they are pairing up, so they only have two electron left, like they are not four. I just said that they have four electron tendency. So two is occupied with another carbon and two is occupied by hydrogen. So you can see here that hydrogen are also present, but there is a slight difference. When you will count the sigma bond, people count this whole as a pi bond. No, we're not gonna do that. This one line, first line is always the sigma bond, but the second line, it is called pi bond. So how many sigma bond is in it? 1, 2, 3, 4, 5. 5 sigma bond. And how many pi bond? 1. Yep. 1 pi bond. How you gonna count multiple pi bonds? See, in this the carbons are sharing 3 electrons with each other, leaving them with only place of 1 hydrogen. So how many sigma bond in it? 1, 2, 3. 3 sigma bonds. And how many pi bonds are there? 1, 2. Yep. So that's it. You have learned types of bonds. That's all. You can say that's all. Now you can, I guess, represent it in many ways. Like, first, there are ways to represent it. Okay, let me get the module. CH in bracket CH3 4. So basically, C have 4 CH3 connected to it. There is a center C carbon. This one is carbon first. Then there is another C. This. Then there is another C. This. Then there is another C. This. Then there is another C. Actually, it should be like this, but it doesn't look great. That's why they say cross. Better. Visually appealing. So yeah. So they're bonding with one electron with C and other 3 with hydrogens. And here it's CH3, CH2, 2, CH3. This can also be written as CH3, CH2, CH2, CH3. You don't have to apply the bracket, it's not necessary. But you can see CH3, C with 3H, CH2, C with 2H, CH2, C with 2H, CH3, C with first C, second C, third C, fourth C. Now you might be wondering, why can't we do a straight line? How the hell are you gonna tell that how many carbon in there in the straight line? That's why zigzag. And This is a functional group. I will tell about it, but you can see it's a bad example. Leave it. Let's stay on the basic for now. Ooh. Moving further, there are organic compounds and functional groups. What are organic compounds? The compounds which are made of organic material. And what is organic material? Organic material are the material which are made up of organic matter. Organic matter means things which are made up of carbon. So basically hydrocarbon. I mean that's a part of it. Okay. Organic compounds has been grouped into classes or families based on their structural features. Yeah, I mean there are definition, dude. There are three types of organic compounds: alkenes, alkynes. These are the main three. I mean there are other types, alkalis. I mean shit, there, but for now there are only three: alkanes, alkenes, alkynes. There is no definition. Yeah, there is no definition. There is simple formula. When you have single pi bond, it is always a I mean when there is or sigma bond, only sigma bond, the whole chain is made up of sigma bond, like C H H H H H. See, there is no pi bond in it, only sigma bond. So this is known as a alkane. This will come under an alkane because there is only sigma bond. Alkene, the thing which will have a single pi bond, not a double pi bond, single pi bond. Remember this, single pi bond means this one, this type of. And what is alkynes? Alkynes are which will have double pi bonds. Easy. There is formula for derivation. Cn, for alkanes there is Cn H2n plus 2. Yeah, you gotta remember it, dude. Somehow or another, I don't care, you have to remember it. Let me give you an example. Cn, wait a minute, focus. H2, wow, what an H, H2n plus 2. So if the n is 1, n equals to 1, equals to C H21 plus 2 equals to CH4, which will be represented as C4H H H H. See, now when we put the n equals to 2, C2 H22 plus 2 equals to C2 H4 plus 2, C2 H6, C H H H H H fucking H, 1 2 3 4 5 6, 6H, 2 C's. Done. Moving further to alkenes. The general formula for alkenes is H2n, Cn H2n, Cn H2n. So when n is 1 equals to CH2 will be represented as no, wait a minute. Yeah, CH2. No. Okay, see, I forgot to tell a simple thing. CH2 can't exist. How, you may ask? Because alkenes, there would be a pi bond, a single pi bond, and for a bond to be pi bond to be happening, you should be pairing it with carbon. Since there is no carbon here, like second carbon, this can't exist. So we will start with Cn equals to 2. So it will go like C2 H22, which is C2 H4. C H4 H1 H2 H3 H4, and here a single pi bond. So see, two C's, 4H. Fucking done. Lemon. Okay. If we take n equals to 3, C3 uh, and H 2 3 equals to C3, it's 6. Now here's the tricky part. C H6 equals to 1H, 2H, 3H, 4H, 5H, 6H. Something is missing. What is missing? Oh yeah, see, gotta remove this H. You may ask how. Because we're gonna form a pi bond and we will supply it with H, single pi bond. So 4 valencies of this one got filled, this one only 3 got filled, but then we will attach it with this one. See, my handwriting is really poor, but try to understand. This will look like this: CH H H. You got a trial and error method. H and H. Oh, this one.